So I have this beacon running as nlam, who is a domain admin. If I try and list the C drive on the domain controller, I have access. Now if I try and jump to it, let's do ps exec first with my SMB listener. It fails. We get this error code 225. We can find out what that means with net help message. So it tells us that the file contains a virus. So this service binary is getting detected by Defender on the remote host. If we try with WinRM, it fails again, and this time we see in the actual PowerShell output that the script's been blocked because it also contains a virus. So this is AMSI. Now if we go into the Cobalt Strike folder on Kali, you'll see an artifact kit folder and a resource kit folder. So the artifact kit is designed to modify the compiled artifacts, so the XEs and the DLLs. And the resource kit is designed to modify the script-based artifacts like PowerShell. In this video, we're going to look at artifact kit. So let's have a look in here. Now I encourage you to check out the README. It contains quite a lot of information about how it works. So the way the artifacts work, or these templates, so if we look into one of the distributions like dist pipe, these are all of the templates that Cobalt Strike will use in its various workflows. So if you want to generate a stageless 64-bit executable, this is the artifact that's grabbed. Likewise, if you generate a stageless service executable, this is the template that's grabbed. And if you look at the size, where are we, dist pipe? If you look at the sizes, you can see that they're actually pre-padded with enough space to fit beacon shellcode. And when you generate a payload from the Cobalt Strike UI, what it does is it grabs the relevant artifact and then patches the beacon shellcode into it. And then when they execute, they load that shellcode. So the point of the artifact kit is to change the way these artifacts actually load the beacon shellcode. In source common, you'll see the various bypass files that control how each of these different distributions actually work. So if we have a look at the bypass pipe, for an example, you can see a whole bunch of code here. The way it works is that it will create a named pipe and then connect to it and write the shellcode into that named pipe, and then it will just read the shellcode back over that named pipe. And the idea is that that's a behavior that is not emulated by like antivirus sandboxes and things like that. Now if we look in the UI, we'll actually see that we already have The UI this whole time has been preloaded to use these dist pipe payloads or templates. And so you will find those in the Cobalt folder under artifact kit and dist pipe. So if we want to modify the service binary, this is the file that we could look at changing, but there's quite a bit of code in here and we don't necessarily know what aspects of this is actually being detected. So that's what threat check is good for. So we run, if we use it to scan the template, with the F, and we are going to scan tools, Cobalt Strike, artifact kit, dist pipe, and what was the file name? Artifact 64 svc big. Artifacts 64 svc big. And the way threat check works is it takes the whole artifact and it tries to split it up into smaller components, and it tries to find the smallest component it can that will trigger a detection. And the way it works is that it finds the end of the bad bytes and then dumps a static number of bytes up from that. So like none of this here at the top is really relevant. We want to start at the bottom. And it looks like one of the things it's not happy with is the pipe name. And that makes sense. This is the default pipe name. And that is down here. So here it is. And it looks like there's a comment here where he's already tried to mess around with it a little bit. But I think the easiest thing to do is just to change these words. So instead of MSSE, we could say raster. And then instead of server, we could say pipe. And then to build these, all you have to do is run the build script. But what I'm actually going to do is I'm going to vim into it. Because what I don't want is to build them all right now. So I only want the dist pipe ones. So that's the 32-bit, which I'm not really going to use, but okay. And then we can run the build script. Okay, so these have all built now into the this dist pipe folder. So these are all our new artifacts now. So we just need to copy these across to the Windows VM. So let's cd into tools, Cobalt Strike, artifact kit, dist pipe, and let's okay. And then PSCP to copy them across. This will be PSCPR. And then this directory. And dist pipe. Okay, so it's those. Okie dokie. Now, let's use threat check again to scan this new version that we've got. So that's artifact 64 big, and now we get no threat found. We don't need to reload this or anything. So now we can just go back to our beacon and do jump ps6x64 dc2 and smb again. And this time we have our beacon.